Okay, hello everybody. Today we're going to start Module 6, and in Module 6 we are going to continue working with linear equations, and we're going to look at all of the different forms in which we can write and graph equations for linear equations. So we're going to start with the most familiar one for most people, slope-intercept form. Homework that goes with this lesson is on pages 200 to 201, 2 through 26 even. And for most of us, you're already familiar with what slope-intercept form looks like. Slope-intercept form of a linear equation is y equals mx plus b. And some of the most important parts we need to be able to identify there are the m that goes right in front of your x, like the coefficient of x in your equation, is always going to represent the slope of your line. And then the b that goes after the mx every time is going to represent the y-intercept. So we need to be able to pick out the slope and the y-intercept when things are in slope-intercept form. And then you're also going to be asked today to take some equations that are not in slope-intercept form. Like for example, this one right here that's in standard form. And you're going to need to be able to solve for y. In other words, kind of rearrange it like we've practiced before, and we'll review that some today, taking an equation like this and solving for y to get the y all by itself so that you end up with something that is in slope-intercept form, where you would easily be able to pick out the slope, the y-intercept, and do our graphs. So we're going to go ahead and go down to the bottom and start looking at some examples. And they're going to start us off with one that is in slope-intercept form. So if we go ahead and take a look at example 1, they want us to find each slope and y-intercept and then go ahead and graph it. So this is already in slope-intercept form, y equals mx plus b. So this is your m right here in front of the x. This is your b right here. And so they just want us to identify those things. So like if this was on a homework assignment, you could just write m equals 1/2. And then for y-intercept, we want to make sure that we pay attention to our signs and notice that that would be treated like a -3 because the sign is going to be attached to it. So when we get ready to graph this, what you want to think about is the y-intercept is actually the first point that's going to go on your graph. I'm going to make a little note that says start graph here. So this is the first point you will put on your graph. If your y-intercept is -3, that means you know you need to be hitting the y-axis at -3. So I'm going to put that dot there to start. And then your slope is how you're going to build more points onto your graph. We've kind of discussed in the last module that slope is rise over run. So what you're going to do from that point is to put your pencil on the y-intercept there at -3, and we're going to rise up 1 square, and we're going to run 2 squares. Rise 1 square, run 2 squares, and we can continue that on. Okay, what I do want to point out is that you can always, once you get a few dots going in one direction, you can always completely reverse the direction. If we went down 1 and left 2, that's going to be the same slope, because if we did down 1, that's kind of like -1, and left 2 is like -2, and a negative over a negative still results in a positive slope. So you can kind of make points in each direction, but then we're always going to connect these with a line and put arrows to show that we understand we could keep adding more dots, but we've kind of run out of room on our grid. Okay, let's try one now on number 2, where if this was so easy to graph when we could easily pick out the slope-intercept in slope-intercept form, it would make sense that we want to be good at changing something that's not in slope-intercept form into slope-intercept form. So to do that, you think you always want to solve for y, or in other words, get the y by itself. So if you would want y to be by itself over here, this 3x would need to go away or move to the other side. So it's basically like you're either taking away 3x on each side, if that's the helpful way for you to think of it, or you could think of it, if I'm going to move 3x to the other side of the equal sign, it's going to become -3x. Either way, your result will be y equals -3x plus 2. We're going to put the x term in front because then it will be in slope-intercept form, mx plus b. So in this particular problem, my slope is -3, and my y-intercept is 2. So like we said, we're going to start from the y-intercept. So y-intercept is 2. That should be the first dot that goes on your graph. And then when we have a slope that's a whole number like this, we would write the slope as -3. But in our minds, we could think, okay, that's the same thing as -3 over 1. So in other words, my rise is -3. My run is 1. So if there is no denominator, treat it as if it's a 1 and watch how that's going to play out on our graph. If I put my pen on the 2 and my rise is -3, I would have to go down 3 for -3. And then my run is 1, so I would go over 1. Again, down 3, over 1. Okay, if we wanted to reverse that, we could go up 3 as in +3, but then left 1 as a -1, because a +3 over a -1 would still be the same as a -3. What you cannot do is you cannot think of that as being a -3 and a -1. If you do that, a negative over a negative will actually turn your slope into a positive, and your line will slant or slope backwards. Okay, let's try number 3 because they do something a little bit tricky with the y or getting y alone. Here is what needs to happen. Y needs to end up alone. The reason this one takes like a little bit of extra thought is because there is a negative sign in front of your y. So the first thing we would be doing is moving the 2x, or just thinking that this is going to come over here and turn into a -2x. But the problem is this will still say -y on the left side, even though you've now moved this over and made it -2x plus 3. So the way you need to deal with that is, some of you are good at understanding it's kind of like we need to divide by -1, but you can also just think to yourself, you need to switch the signs on everything. So you need to make that a positive y, you need to make this a positive 2x, and you need to make this a -3. And now we're officially in slope-intercept form. So y equals 2x minus 3 would have a slope of 2 and a y-intercept of -3. Your starting point for your graph would be at -3. Your slope is 2, so you can think of that as 2 over 1, where your rise would be 2 and your run would be 1. So from this dot, I'm going to go up 2 squares, right 1, up 2 squares, right 1, up 2 squares, right 1, and so on. Okay, so here's some basics for how we're going to do slope-intercept form. We're going to go ahead and flip it to the back side to do a little bit of extra work. Okay, so back here, let's go ahead and have you take a second to create a header that says creating linear equations in slope-intercept form. So we're going to take a look at page 197, your turn. So I'm going to get a book here while you're setting up your paper. Okay, and we're going to start on page 197 by looking at your turn number 3. So what's going to happen in some of your problems is they're not going to give you an equation right off the bat. You're going to have to create it. So it says write the equation of each line in slope-intercept form, and look at what they've given you in number 3. They're telling you the slope is -1 and 2 is on the line. So I'm going to make a note here of what information that I was given in number 3. And they're telling me the slope is -1. So in other words, that's my m. And 2 is on the line. So what I have is I need to write an equation in slope-intercept form, which is y equals mx plus b. So I'm literally going to write down y equals mx plus b because that's my goal. And I have been given the slope, but I have not been given the y-intercept. So I have to consider what else I've been given. This point right here is not my y-intercept. But what it is when I'm given an ordered pair, that's an x and a y coordinate. So if you look at this format, which is why I want you to write it down every time, there's an x and a y in this format. So we know the m, we know the x, and we know a y. We just don't know b. But if we had all those other three pieces plugged in, we could totally find b. So that's what we're going to do. We're going to plug in this 2 as my y. We're going to plug in the -1 as my m. We're going to plug in the x as being 3. And then b will be the only thing that we don't know. So we're going to solve this equation for b. So go ahead and multiply the two numbers you have side by side here. -1 times 3 is -3. So I currently have 2 equals -3 plus b. To solve for b, all I need to do is add 3. I'm going to get 5 for b. So I now have m and b. They want me to write an equation in slope-intercept form. My equation is y equals -x plus 5. So you're going to notice I put -x instead of... So what you're going to notice is that I put -x instead of -1x because we don't truly need the -1 right there. So let's try again. If we look at example 4, they give us a different piece of information. In example 4, they just tell us, hey, your line passes through 1, 4, and 3, 18. So they give us 2 points instead. So I'm going to write a note here. Line passes through 1, 4, and 3, 18. So we're going to have to approach this one a little differently. So you stop and think about it and say, okay, I'm supposed to write an equation in slope-intercept form. And they haven't given me a slope or an intercept. So you have to get intelligent here about what you're going to do. I would say, since slope-intercept form, one of the first words is slope, we probably should find a slope. So think about what you know from the last chapter about how you can find a slope when you're given 2 points. And hopefully right now, the slope formula of y2 minus y1 over x2 minus x1 is kind of flashing through your memory. So I have 2 points here. This could be my x1 and y1, and this could be my x2 and y2. And I'm just going to plug those in to find the slope. So my y's would go on top. I would have 18 minus 4 on top. Okay, my x's would go on bottom. I would have 3 minus 1 on bottom. So that's going to leave me with 14 over 2, which is 7. There we go. I have a slope. My slope is 7. Okay, now from that point, what we're going to do is we're going to treat it like we did in the last problem. We want y equals mx plus b, and at this point now we've figured out an m. We still don't have a b. But we have 2 x's and y's to choose from. So you could literally choose either pair. I'm going to go with this first pair because it's smaller numbers. And we're going to do what we did in the last problem. We're going to plug in our y coordinate is 4. The m that we just found was 7. The x from this point right here was a 1 plus b. So I've got 4 on the left side. 7 times 1 is just 7. And if I want to solve for b, I need to get rid of the 7. So minus 7, minus 7. I'm going to get -3 for b. So there we go. I have an m, I have a b, put it all together. Y equals 7x minus 3. That would be my slope-intercept form. So the things we have to remember is that if you're going to do slope-intercept form, you need a slope and you need a y-intercept. If they give you the slope, great. Start there and plug in the other x and y that they give you. It's a little bit less work. If they don't even give you a slope, that's where you got to start first. You have to find the slope first, and then you can use either pair of x and y coordinates to help you find your y-intercept or your b. So last thing on notes, we're not going to do any word problems together right this minute, but some things that you're going to be looking for when you read your word problems today. They're going to give you some problems and ask you to write an equation to represent the situation in slope-intercept form. So that means you're going to be reading for information to try to figure out what is the slope they're telling me here and what is the y-intercept. What we want to remember for these is that when you guys are dealing or looking for slope, another way we said you can say slope is rate of change. Somewhere in each problem, they're going to be describing to you something that is changing. However quickly it's changing, the rate at which something in this problem is changing, that's your slope. Okay, if they describe to you someone's quiz grades that are going up by 5 points every time, okay, or someone's speed who is increasing at 2 miles an hour every time they ride their bike, right? That's a rate of change. Y-intercepts, you're going to be looking for something that either talks about what the initial amount or the starting point was. So if they talk to you about, hey, this guy had a bank account and he initially put $360 into it, there's your y-intercept, okay? Or wherever someone started from, kind of the initial original starting point that they speak about in a word problem. That should be your clue that you're looking for the y, or that you're looking at the y-intercept. So, good luck with slope-intercept form. Homework is on pages 200 and 201.